Section 2.1, Functions and their Graphs. This is still a review of pre-calculus topics for a little bit, and then later on in this chapter, like in 2.5, we'll get into some calculus topics. So enjoy the review while you can. Hopefully you remember what a function is. A function is denoted typically using f of x notation. The definition of a function is that for every input, that is x value, there is exactly one output. That is the y value. And hopefully you remember what a domain is. The domain of a function is all the x values that make sense, all the input values. And the range is the opposite. It's all the y values that arise from the x values from the function notation. Something else that you might hopefully remember is the vertical line test, which is used to determine if a graph represents a function or not. So a quick example, if you have a graph of a function, this is a function, since if you draw a vertical line, it'll cross the graph at only one point. On the other hand, a circle will fail the vertical line test because it crosses the graph at more than one point. Okay, so we'll go on to how the function notation works and finding the domain and graphing some functions and some applications. So we're going to move on to the worksheet here for section 2.1. Please find that in WebAssign. The very first question that I have on the worksheet, the function f of x is defined as this polynomial, and we need to determine f at -1. So hopefully you remember this means that -1 is going in the spot for x. So it's 2 times -1 squared minus 3 times -1. Remember that exponents come before multiplication, so we'll do this first. So it's 2 times 1, 2 negatives, positive 3, so you get a 5. For the next one, it's f of a, so replace x with a. It's 2a squared minus 3a, and these are unlike terms, so you can't really do anything with that. You just leave it the way it is. For the next one, the input is a plus h. So your input, instead of x, you have a plus h quantity squared minus 3 times a plus h. Now remember the caution that I'd given you way back in chapter 1. If you have an addition, you can't distribute the powers, and you cannot distribute the 2 and yet either due to the order of operations. Instead, you're going to figure out what a plus h times a plus h is just by doing the FOIL process. So it's a squared plus ah plus ha, or ah, alphabetical order, h times h, finally is h squared. These two add up, and you'll notice that this happens a lot from here on out, so after a while you'll have it memorized. A squared plus 2ah plus h squared. Then distribute the -3, so it's minus 3a minus 3h. Distribute the 2, 2a squared plus 4ah plus 2h squared minus 3a minus 3h, and look carefully, there aren't any like terms, so you would leave it the way it is. Okay, the next question, this is going to show up the domain, finding domain of functions all the way from here on out till the end of the semester. So it's going to be a topic, we'll see it over and over. To understand domain, what you need to know is that this is a polynomial, and the domain is all the x values. What x values can you plug in? Well, I think you can plug in 2 for x, you can plug in -10, you could plug in 100. There's really no limit to what you can plug in. So generally speaking, a polynomial is a really nice function, and its domain is a set of all real numbers. So you can say all reals, or you can denote it using the interval notation, the entire number line, or there's a shortcut notation for all real, the set of all real numbers, using what's called the script r. You do the r with an extra line. This represents a set of all real numbers. Alright, so the next problem, we'd seen these earlier too in chapter 1. This isn't a polynomial, but a ratio of two polynomials. and we call them rational. So this is a rational function. And as you can see here, because of the denominator term, there is some issue there. X can't be 3 because 3 squared is 9 minus 9 is 0. X can't be negative 3 as well because negative 3 squared is 9. 9 minus 9 is 0. So basically you're looking to see when x squared minus 9 is 0, and to solve this you can add the 9. And you may recall the square root property from algebra. X is plus or minus the square root of 9, which is plus or minus 3. So the domain, you would write the answer is x can be any real number except it cannot be plus or minus 3. This is good enough as your answer. For the last question, there's two issues here. One is the denominator term. You can't have 0 here. Okay, can't be 0. So 2x minus 1. If it were 0, what would that give you? Add 1 to both sides, divide by 2. So essentially, for half the problem here, x cannot be half, because if x were half, you'd have a 0 down there. Something else to consider is under the square root, you can't have a negative term. You don't want a negative under a square root because it leads to imaginary numbers. So you want 3 minus x to be greater than or equal to 0. It has to be positive or 0, but it cannot be negative. To solve this, I'm just going to add x to the other side, save some work, and read it in the opposite direction. You want x to be less than or equal to 3, but not equal to half. So going back to the answer, x is not half, x is less than or equal to 3. Alright, so domain is a tricky topic. The textbook has more examples. I encourage you to look at it. The next part of the section is a topic that shows up very frequently in this class. And this is something, ignore the 0. This is called a piecewise function. We have actually seen piecewise functions. In section 1.2 we saw the absolute value of a function. That was a piecewise function. It was a if a is greater than or equal to 0, negative a is if a is less than 0, 2 pieces, so it's called piecewise. And here we have 2 pieces as well. The way you understand this is it's saying that this function is x minus 2 for certain input values that are less than 1 or equal to 1, and that it's equal to x squared if x is greater than 1. So when I ask you to evaluate f at negative 2, where does it fall? Is negative 2 in this category or the other category? Well, negative 2 is not greater than 1, it's less than 1. So it's this function we're corresponding to. So f of negative 2, plug in negative 2 here, and you get negative 4. F at 1, when the input is 1, it does not fall here, but over here. So it's 1 minus 2, and that's negative 1. And finally, f of 2, 2 falls in this category, it's bigger than 1, so it's defined to be 2 squared, which is 4. Now, when you sketch the graph of these functions, you can use a calculator to help you as a guide, but you need to understand that you're going to have a line for this piece and a parabola for that piece. For x greater than or equal to 1, here's 1. To the left of 1, it'll be a line. So how do you use a calculator for this? Go to y equals and type in x minus 2. I'm going to go zoom 6 for a standard window. I push trace. I'm going to type in 1. At 1, the y value is negative 1, so I'm going to plot that here with a solid dot because it's an equals right there. Then I'm going to type in one more number like 0, and I get negative 2, which I knew. So here's that piece. You ignore the rest of the graph because it does not correspond to that part of the if statement. Now we know x squared, the graph of x squared is a simple old parabola. I'm going to show you anyway on the calculator. Push trace, type in 1. When x is 1, y is 1, but right there I have an open dot. At 2, just to get another point, the y value is 4, and there's a rough graph. So this piecewise function needs to still pass the vertical line test. If I draw a vertical line, it is a function, so I haven't made any mistakes. Last question. It's an application, very simple one. Clark's rule is a method for calculating pediatric drug dosages based on a child's weight. If A denotes the adult dosage in milligrams and if W is the weight of the child in pounds, then the child's dosage is given by that function. If the adult dose of a substance is 500 milligram, like Tylenol or Motrin, how much should a child who weighs 35 pounds receive? So adult dosage is A. There's A. So it's 500 times W. W is the weight of the child, and the child weighs 35 pounds, divided by 150. So what we just calculated was D of W, which is D of 35. And you can calculate that real quick on your calculators. 500 times 35 divided by 150. I'm getting about 116.6 repeating. That would be milligrams. So that would be, if an adult gets 500 milligrams, correspondingly the kid gets a lot less, obviously, and only that much. Now, sometimes students make the mistake with notation of functions. They divide both sides by 35. That's not right, because this is not a multiplication. Rather, this is a placeholder. It's telling you that when the input is 35, this is the output. Alright, this is the end of section 2.1, short section.